Another example like the one we just did before. I'm going to simplify the square root of 48 x to the 5th y squared times the square root of 50 x squared y to the 4th. As promised, I mentioned that in this one I will multiply whatever's underneath the radicals first and then simplify, which is another option. And I can multiply here because my index is the same. Take 48 times 50. And we get 2,400. And then have x to the 5th times x squared. That gives us x to the 7th power. And y squared times y to the 4th would give us y to the 6th. This is kind of nice so far, a little less simplifying to do right off the bat. Now we have to simplify our square root of 2,400. Let's think of a perfect square that goes into 2,400, and the one that I noticed right away is 100. 100 times 24. And then x to the 7th. You can either write this as x squared times x squared times x squared times x, or you can also just do x to the 6th times x, x to some power that's divisible by 2, and then y to the 6th. And the same thing, we can work with that just in the form y to the 6th also. Okay. Now let's square root what we can. The square root of 100 is 10. That comes out of our radical. I'd have 24 underneath. The square root of x to the 6th would be x cubed. I have this x underneath still. And then the square root of our y to the 6th is y cubed. We can simplify our square root of 24 a little bit also, because 24 is 4 times 6. Square root of 4 is 2. Times the 10 that's already there, we get 20 x cubed y cubed. Square root of, we still have this 6 and this x underneath our radical. We're almost there. The last thing we have to think about is whether we need absolute value or not. This is the fun part. So since it's square root, we in theory will need our absolute value. So put it in, and then we can think about if we actually need it or not. The 20 again, 20 is always positive. We don't need it there. X cubed, since this is an odd power, we in theory would need it. But then look back at my original problem. Could x be negative up here? Well, if x is negative, and I add x to the 5th power, that's going to be negative, which means I'd have the square root of a negative, and that's not good in our situation. So this x cubed really has to be positive. The y cubed that we have is kind of a different situation though, because again, since it's an odd power, we would need it. Double check the original problem. Could y be negative? Yeah, if I had a negative number squared, that's okay. If I have a negative number to the 4th power under a radical, that's okay also. So this y cubed could be negative. We need the absolute value here. My final answer is 20x cubed times the absolute value of y cubed times the square root of 6x. We'll get a lot more practice with this too as we go throughout the chapter. And this is kind of something that the more you see it and the more we talk about it, the easier it'll get, the easier it will be to figure out when you actually need it.